question 3, we're dealing with the t-distribution now. Just as a reminder, when do we use the normal distribution, our z-tables, versus our t-distribution, our t-tables? Basically, it has to do with whether we're given the population standard deviation or not. So if we're trying to find a confidence interval for the population mean, and we have the population standard deviation, we'll use our normal distribution. If we're trying to estimate the population mean, but we don't know the population standard deviation, which is often the case, we'll use the t-distribution instead. The t-distribution is very much like the normal distribution. It looks very similar, but it just has what are called heavier tails. So there's more information, more of the data is in the tails. So the tails are larger compared to the normal. Okay, so this question is all about how to use a t-table. So let's say we are trying to build a confidence interval for the population mean, and it's a case where we don't know the population standard deviation. To make a confidence interval, remember we always need to find the margin of error. In the margin of error, we take our z or our t statistic and we multiply it by the standard deviation. So how do we find our t statistic, our t value, for a given confidence level and degrees of freedom? As a reminder, degrees of freedom, when we're dealing with the t-distribution, is n minus 1. So our sample size minus 1. So here it gives us our degrees of freedom and our confidence level. So just as always, our confidence level, 1 minus, see if I can draw a good t-distribution, 1 minus the confidence level gives us the area in both the tails. So 1 minus 0.99, 99%, is 1%. So I know that in both tails, there's 1% of the data total. So I know that in one of the tails, there's half of 0.101, which is 0.005. So let's find the t value, the t statistic, corresponding to an area to the right of 0.005 and degrees of freedom equal to 13. So let me go down to my t table. So I wanted, remember, area to the right of 0.005, half of 1%. And you'll notice that the t table is in terms of areas to the right, unlike the normal table. So 0.005 is this column. And what was my degrees of freedom here? It was 13. So I want df equals 13. So I look at this column and I go down to degrees of freedom equal to 13. You'll notice that's what this column is. And I find that the t statistic value corresponding to that is 3.012. So I know that my t statistic is 3.012. And that's it for this question. Now let's suppose our confidence level is 95% and our sample size is 36. So first I'll find the area to the right of my t statistic that I want. So now my area in both tails is 1 minus 95%, which is 0.05. So the area to the right, area in just one of the tails is 0.05 divided by 2, which is 0.025. Then I don't have degrees of freedom, I have my sample size. But remember that degrees of freedom are just equal to the sample size minus 1. So I know that my degrees of freedom is just 35. And I need the degrees of freedom for reading the t-table. So I have my area to the right, 0.025, my degrees of freedom of 35. Down to my t-table. Now I want 0.025 and 35. So let's look. 0.025 is this column here. Let's look for degrees of freedom of 35. So my t-statistic is 2.030. And that's it for part B. Alright, last one, part C. Now our confidence level is 90% and our degrees of freedom are 16. So my area in both the tails together is 1 minus 90%, which is 10%. My degrees of freedom are 16. So if the area in both the tails is 10%, the area to the right in just one tail is 0.1 divided by 2, which is 0.05. So I know that the area to the right is 0.05 and my degrees of freedom is 16. So let's now look that up in our table. Let's see, so 0.05 is this column. Degrees of freedom of 16 is this row. So my t-statistic that I want is 1.746. And that's it.